All right, everybody. 7.4 is division properties of exponents. So remember back when we did 7.2, we did multiplication properties of exponents. We had to add the exponents. So here, when dividing numbers with the same base, we're going to subtract the exponents. And before I move on, I almost forgot, remember to go grab the notes guide if you would like to, so you don't have to write down as much stuff. Okay, so hopefully that makes sense that multiplying, we add the exponents, dividing, we would subtract the exponents. So again, just like I have for the last few days, I'm going to show you what the answer is and why it is the way it is for this first one. So like the rule says, I'm just going to subtract these exponents. 7 minus 2 is 5, so this would be x to the fifth. Okay, so if I would, again, same way, if I would expand this all the way out, all 7 of these x's, 3, 4, 5, 6, and 7, over 2 of them here, and just cross off the ones that match up with each other, you can see that there are 5 left right there. Which is why, again, instead of doing that, we just need to remember that when we're dividing, all we got to do is subtract the exponents and we're good to go. So again, you're going to see several things in here, though. Like I told you the other day, that even though this is 7.4 and this is dividing, you're going to see multiplying. You're going to see power of a power from 7.3. You're going to see negative exponents just like in 7.1. So it's kind of a combination of all three in addition to what we're doing here. Like this one, this next example. So this is kind of one that we could have seen back in 7.3, but it's in here instead. Okay, so we have an exponent on the outside of our parentheses, right? There's 4 out here on the outside, so everything on the inside is going to the fourth power. So like I said the other day or yesterday for 7.3, it's like we're going to distribute, but we got to remember we got to do it to everything inside of those parentheses, which means this 2 has an exponent of 1, so I'm going to multiply that one by 4 as well. So this is going to be y to the 16th over 2 to the 4th. And then with my nice little calculator, I can do, 2 to the 4th power, which is 16. Okay, so that one really wasn't part of the division rule, even though it was a fraction, because those, the y and the 2 don't have the same base, so I can't subtract the exponents there. Okay, next, x to the third over x to the negative 7th. Please be careful with your subtraction. 3 minus negative 7 is 10. Okay, that's typically one where people make mistakes simply because they subtract wrong. So make sure you're careful with that part of it. All right, next one. Now we're going to jump it up a little bit, as you can see. So the first ones just had one thing. This one I put 3 things in it. Okay, a number and then 2 different variables. But we are going to do a couple things. I'm going to show you something here as well. Okay, so we can do this 2 ways. Okay, we can do this one of 2 ways. Is I can just go ahead and subtract every single exponent. I'm going to put a 1 here on the x before I forget. So I could do 2 to the third over 2 to the fifth is 2 to the negative second. 4 minus 1 is 3 for the x's. 2 minus 5 is negative 3. And then I could take my negative exponents and change it to positive exponents and do it that way. I don't like to do that. I'm lazy. I like to do it a little bit quicker than that. Here's what I like to do. Whoops, not mess up my iPad. There we go. Is I like to do it this way. I look at it this way. I am still going to subtract all my exponents just like it says to do. But what I look at is where is there more? Okay, so I have 2 to the third in the numerator and 2 to the fifth in the denominator, right? So that means there's more in the denominator. So the difference between 5 and 3 is 2. And since there's more in the denominator, then I'm going to leave 2 to the second power in the denominator. Okay, looking at my x values. X to the fourth over x to the first. So 4 minus 1 is 3. There's more in the numerator, so x to the third is going to stay in the numerator. And then last, y to the second over y to the fifth. 5, the difference between 5 and 2 is 3. Again, there's more y's in the denominator, so y to the third is going to stay here. And doing it that way will prevent me from having to worry about negative exponents. Okay, and then having to do that extra step of rearranging, changing, and all that kind of junk. Okay. Now, the only thing I am going to do, though, is 2 to the second is 4. So I'm going to simplify that. And here I am done. I cannot do anything else. That's an x and a y. Those do not have the same base, so I can't do anything with those exponents. Okay, all right, let's keep on rolling. Here's another one where we have an exponent on the outside and on the inside, and this is something too. You think about order of operations, parentheses first. If you go inside these parentheses, there's nothing you can do. Okay, so I'm just going to throw a 1 on everything, and then we're going to take everything to the third power. So that would be 7 to the third, x to the third, and y to the third in the denominator. Okay, so 7 to the third power is 343, x to the third, and y to the third. Again, done. Nothing else we can do. The x and the y, that's not the same base, so we can't do anything there. All right, last but not least, this is a biggie. Okay, here's the first thing I'm going to do. So some of you might be looking at this and seeing different things of what do I need to do first. Okay, and that's the nice thing about these is you can do this stuff in kind of different orders if you would like. I personally like to keep it consistent with order of operations, whereas I have parentheses. I'm going to go inside those parentheses and I'm going to see if there's anything that I can simplify. Okay, and if I look at that, there is. I have these x's, I have these y's. All right, so I can simplify those. The 4, I can't do anything with that, so I'm just going to leave it alone up there in the numerator. Okay, so remember, I have x to the first there and x to the fifth in the denominator. Select the one up above. The difference between those two things is 4, and since there's more in the denominator, I'm going to put x to the fourth in the denominator. And then with the y's, the difference between the y's is 2. There's more in the numerator, so I'm going to put y to the second up in the numerator. Okay, still have this whole thing to the negative second power. Now here I have two options. Okay, here I have two options. Option number 1, I can take that negative 2 on the outside and I can multiply it by every exponent on the inside. Okay, and that would work just fine. I like to do something else. When I have the negative exponent out here and a bunch of stuff inside those parentheses, I like to take care of the negative exponent first. So as always, how do you make a negative exponent into a positive exponent? You flip everything over. So I'm going to do that. I'm going to do x to the fourth and put that on top, and then put 4y to the second on the bottom, which would now make this a positive 2 instead of a negative 2. Yeah. Okay, and then last, I'm going to change colors one more time. And then the last thing I'm going to do now is, that's 4 to the first, so I'm going to multiply every exponent on the inside by 2, and that should just about finish it up. So that gives me x to the 8th, 4 to the second, y to the 4th, and I was wrong, not just about finish it up. 4 to the second is 16, so I'm going to do that. Okay, so as you can see, as now that we have we have 3 different exponent properties that we can use. Okay, when I multiply, I add the exponents. When I have an exponent to an exponent or a power to a power, I multiply the exponents. Did I mess up the first one? When we're multiplying numbers, we add the exponents. Exponent to an exponent, we multiply them. And then last today, 7.4 is when I'm dividing, I subtract. Okay, so this very last problem combined several things together. Just want to kind of, so we see that. So we had the division rule where we subtracted the exponents. We had a negative exponent, so we did reciprocals from 7.1. Okay, and then we did from 7.3, we did exponent to an exponent. So this one problem had 3 different things in it. Stuff from 7.1, from 7.3, and from 7.4. So expect that, or don't be surprised to see those things when you're doing the assignment for this today, where you're going to have multiple ways to do it. Stuff from earlier in the chapter as well. Okay? All right, that's it. If you're working on the assignment, as always, let me know if you need any help. Email me, ask me a question, whatever you got to do.